we are going to test hardness of water sample. Aim of the experiment to determine the total hardness of water sample by complexometric method using EDTA. We should know what is hardness. Hardness is the property of water which prevents lathering of soap. Hard water does not produce lather or foam when treated with the soap. Hardness in water are two types: temporary hardness and permanent hardness. Temporary hardness causes due to the presence of bicarbonate salts, and permanent hardness causes in water due to the presence of chlorides and sulfates of ions. Basically, magnesium calcium salts of chloride and sulfates of ions causes in water. Hardness can be removed by boiling, but permanent hardness cannot be removed by boiling. Expressly in milligram per liter or ppm. Standard hard water. Hard water whose hardness is known is called standard hard water. What are the apparatus required? This is conical flask. This is a measuring cylinder. This is beaker. And the required chemicals are standard hard water, EDTA, this is the indicator EBT, and this is buffer solution whose pH is in between 8 to 10. Move to procedure part. Determination of hardness consists of three parts. First part is standardization of EDTA. Second part is determination of total hardness, and third part is determination of permanent hardness. So before performing experiment, you should wash all the apparatus clearly, and next need to proceed. Let's rinse. EDTA solution in the burette by using funnel. Solution and fix the burette in the burette stand. So EDTA we take 25 ml of standard hard water. Transfer into the conical flask. Buffer solution to it by using funnel. To 4 drops of EBT indicator to it. EBT is European black tea. Naturally, it is blue in color, but when it becomes complex with calcium and magnesium ions, it becomes a wine red complex. When it becomes complex with the calcium and magnesium ions, and after titration with titrant, which is taken in the burette, it comes out endpoint blue in color. Initial bureau reading 0. Now it is blue in color. This is the endpoint. Use double observation for the standardization of EDTA was 0. Concordant reading, concordant reading take of the two observations. Then similar flow, add 10 ml buffer solution to it. EBT indicator, and between the period. Reading was 37.1, and total hardness. Total hardness we use supplied hard water instead of boiled water. Both permanent hardness and temporary hardness. Take 25 ml of supplied hard water. And now transfer into the conical parts. Or buffer solution to it using anel. Transfer to the conical parts. Add 3 to 4 drops of EDTA indicator. Straight with the titrant. Initial bureau reading is 0. When calcium or magnesium salts react to the EDTA, it is weak acid, but when it comes in contact with EDTA, it becomes strong. And in the influence of a strong EDTA, it comes out to blue in color. 0 comes out 5.1. Other two observations for to get concordant reading. Other two observations for concordant reading for to get permanent total hardness. Determine permanent hardness. To determine permanent hardness, we use boiled water. So take supplied hard water and then boil it gently in a hot plate. Permanent hardness, we use supplied hard water, 25 ml supplied hard water, and boil gently in a hot plate for 10 minutes. Cool and it needs filter. extra distilled water to get the same value. Ten ml buffer solution. To 4 drops of a EDTA indicator. And titrate with the titrant till endpoint comes. Blue color now proceeds. So this is endpoint. Eight point. Concordant more two readings. We need to do other observations and note down the concordant reading. Total hardness. First is standardization of EDTA. Next total hardness, and finally we get permanent hardness. Is to get permanent hardness for 10 minutes in a hot plate and remove temporary hardness. That means calcium or magnesium bicarbonate has been removed by boiling, and to get permanent hardness. This is how.